Okay, so basically, obviously yesterday we did some like instantaneous rate of change, average rate of change, but we also have ones where we're like looking at a graph and telling what happens, which we kind of did this in physics, obviously to an extent. But basically, a particle P moves on the number line shown in part A, accompanying a figure. Part B shows the position of P as a function of time. So that would be the graph. So then we're just looking at part A here, but when is P moving to the left, right, and standing still? So I usually just go ahead and set up like left, right, and still, and then as I go across my graph, I'll just fill in the timelines of them. So these are going to be intervals like a number less than or equal to, T is less than or equal to another number to fill them in. So obviously we start at 0 and then we're going up. So if it has a positive slope, that means it's moving to the right. If it's like flat across the top, so a 0 slope, then that means it's not moving. And then if it's got a negative slope, it's moving to the left. So basically from 0 to 1, it is going up, so that would mean it's going to the right. So we would do this as 0 is less than or equal to T is less than 1, though, because 1 is also part of the next interval. So we're not including it there. Basically, it's only the beginning and the end, like when it starts moving and when it stops moving, that we're including. Otherwise, we're not. So then from 1 to 2 seconds, it is flat, so that would be still. So 1 less than T less than 2. Then from 2 to 3 seconds, it has a negative slope, so that would mean it's going to the left. So 2 less than T less than 3. Now from 3 to 5 seconds, it's flat again, and it's going obviously straight across. So this one will be an interval of covering 2 seconds. It's still from 3 less than T less than 5. And then finally, it's going, or has a negative slope for 5 to 6 seconds, which would mean it's moving to the left. So 5 less than T, and then because we know 6 is the ending, less than or equal to 6. Number 11 will be one that I think I have for you to do in your homework problems. You would only have to do parts like A and B. You wouldn't be doing the other stuff. But like one of the questions is, when does it reverse direction? So that's just like basically when does it go, obviously at what point is it changing from like a positive slope to a negative slope, pretty much is what you're looking at. And that's obviously just going to be at an individual point in time. That's not going to be anything like over a span of time. It'll be when you see like a hard change in the graph, like a V or something like that. But since this one didn't ask that, and there's nowhere that ours does that, just wanted to mention that. Okay, free fall. So number 14. The equation for free fall near the surfaces of Mars and Jupiter, S in meters and T in seconds, are for Mars. We have S equals 1.86 T squared. And then for Jupiter, it is S equals 11.44 T squared. How long would it take a rock falling from rest to reach a velocity of 16.6 meters per second on each? So the velocity that we're trying to get to is 16.6 meters per second. Now, I have the equations for position. To find velocity, we take the derivative of position. So I need to first do that. So to get velocity on Mars, then I would need to take the derivative. So that's going to end up giving me, let's see, 12, 16, 17, 2, 3, 3.72 t. And then I'll go ahead and do it for Jupiter, and then we can solve. The velocity on Jupiter is going to then be, is that 22.88, I think, times t. So obviously these ones started from rest, so we don't have to have like the crazy equations. But to find I'm trying to figure out how long it took for it to reach that velocity. I basically am just solving for t, so I'm plugging in this velocity value both here and over here, because we want to know on each planet how long it takes to hit that. So I would have 16.6 divided by, in this case, 3.72 is equal to t. And then over here, 16.6 divided by 22.88 is equal to t. And let's see. Whoops. This one is 4.46 seconds. This other one is 0.73 seconds. And that's all we have to find on those ones. Particle motion problems here. Number 20. A particle moves along a line so that its position at time t is greater than or equal to 0, is given by the function s of t equals negative t cubed plus 7t squared minus 14t plus 8, where s is measured in meters and t is measured in seconds. And so A, they want us to find instantaneous velocity at any time t. So that literally just means take the derivative of the equation and we don't have to do anything with it. So what would the derivative of my position equation be to give me velocity?
Negative 3t squared plus 14t minus 14.
Yep. So that would be our velocity equation. If we were trying to find velocity at a specific time or whatever, we could now use this equation. Part B says to find the acceleration at time t, or any time t, but so I don't know if we talked about this yesterday or not, but so the derivative of position is velocity. The derivative of velocity is acceleration. So I need to take the derivative of velocity to find acceleration, and what would that be?
Negative 6t plus 14.
Yep. There is one more thing. I don't think it occurs in this chapter. I think it occurs in a later chapter, but if you take the derivative again of acceleration, you get something called jerk, which I don't even have a full concept of what that is. But anyways, but it's like the thing after acceleration, and you don't really talk about it in physics, at least not in like the physics that we do. Anyways, but they may ask you for it. But typically that's getting you down to just like a singular number left over, obviously. So then, when is the particle at rest? We're taking our velocity equation and setting it equal to 0 to find that. So we would have negative 3t squared plus 14t minus 14 is equal to 0. You hope and pray that this factors, and if it doesn't, then you get to use the quadratic formula, which I will tell you probably the most of the time you're going to be stuck using the quadratic formula because unfortunately the numbers aren't typically very nice. This one does not factor, so we're going to have to use the quadratic formula. So negative 14 plus or minus the square root of 14 squared minus 4 times negative 3 times negative 14 all over 2 times negative 3, so that's negative 6 on the bottom. And pretty much at this point I would grab my calculator and do it, and obviously you'll have two different answers when you do it because you've got the plus or the minus under the thing. So sometimes I like to just do it under the radical first and get that value and then go from there. If I did this right, then what's under the radical is just 28. Then we just have to split it up. I got 1.45 seconds and 3.22 seconds. But I don't know if you checked that, if you got the same thing or not.
You got what?
1.45 and 3.22.
I'm not reading. I got 12.3. Oh wait, I know. You said everything inside the radical is 28.
That's what I got, I think so. Let me check it again and make sure. Yeah. So, like, it would be like the square root of 28, obviously. Like, I didn't take this, yeah.
Okay, yeah, I got that.
Okay. Normally, I would use the, like, put it in a giant fraction and do it. I just kind of just did it step by step when I did it this time, though. Two more. 24. Finding speed. A body's velocity at time t seconds is v equals 2t cubed minus 9t squared plus 12t minus 5 in meters per second. Find the body's speed each time the acceleration is 0. So basically, this is kind of a interesting problem. Basically, what we have to do is we need to find the acceleration equation. We're going to have to set that equal to 0 and solve. Then at the two times where acceleration is 0, we're taking that and plugging it into this velocity equation to find what the speed was at the time. And obviously keeping in mind speed is the absolute value of velocity, because velocity would be giving us a direction technically.
Yeah.
All right, so acceleration is equal to 6t squared minus 18t plus 12. Now, at this point, before I do anything else, I would probably attempt to factor out a 6 to make my numbers easier. So then I would have t squared minus 3t plus 2 before I set it, or like when I set it equal to 0, because then obviously the 6 will go away. And then what would this factor into? Because those are nice, easy numbers.
It would be t squared minus 2t minus t plus 2.
Yeah. If you wanted to go straight to t minus 2 and t minus 1, you could also do that. Since it just, because I've eliminated the number in front, if I didn't, then I would have to write it as the t squared minus 2t minus t plus 2 or whatever.
And you like eliminated it by just like dividing it to 0.
Yeah, because 0 divided by 6 is, yeah. If I wasn't, like if I was just trying to find the acceleration equation, I would have just left it the way that I wrote it initially. But since I knew I was setting it equal to 0, like instead of trying to factor factors of 6 and 12 that give me negative 18, I was like, let me take a 6 out and make it easier.
Yeah.
I mean, you ultimately are going to get the same thing, but. So then I would have t equals 2 or t is equal to 1. So at 1 second and at 2 seconds, acceleration is 0. So now I need to find the speed at both of those values. So then v of 1 is going to be 2 times 1, I'm not even going to write the cubed, minus 9 times 1 plus 12 times 1, and ultimately I don't even need to write the ones, but just to see how we're plugging them in. So I've got 2 minus 9, negative 7, plus 12 is 5, minus 5 is 0. So that means that the velocity is also 0 meters per second when the acceleration is 0 at 1 second. Then at 2 seconds, v of 2 is 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 5. So that's 8, 16, 4 and 9, 36. So minus 36 plus 24 and then minus 5. So that's, let's see, negative 20 plus 24 would give me a 4. Minus 5 is negative 1. So the velocity is negative 1, but I'm technically finding speed, right? I think that's what it said. Yeah, find the body's speed. So that means that's the absolute value of velocity. So the absolute value of negative 1 is equal to 1 meter per second. That would be my speed. If it's already positive, obviously we don't need to do that, but some questions that we're going to get to eventually, again, not in this section, but it'll basically it'll tell you to find like the position, or you'll be given position, and then it'll tell you to find like velocity, speed, then acceleration, and then all the way down to like jerk, like, which again is just the next derivative of that. But this one just obviously wanted speed. All right, one last question, that's rate of change. 34. This is inflating a balloon. The volume, V equals 4/3 pi r cubed of a spherical balloon changes with radius. And this is one of those equations that you're going to need to know for the AP exam, like that they would expect you to memorize. Part A, at what rate does the volume change with respect to the radius when r is equal to 2 feet? So the first thing I need to do is I need to take the derivative of the volume because that's how I'm going to get my average rate of change or my rate of change. So dV dr, and what would it be when I take the derivative of that initial equation?
4 pi r squared.
Yep, 4 pi r squared. And then we want it when r is equal to 2. So at this point now I'm going to plug in 2. So 4 times pi times 2 squared. And a lot of times what you're going to find is that they're going to leave it in terms of pi. So they're going to say like 16 pi. And then the units on these are a little weird, but it's cubic feet of volume per foot of radius. Or you could say feet cubed of volume per foot of radius. It's kind of a lot, but that's technically the units on there. So then the second part just says by approximately how much does the volume increase when the radius changes from 2 to 2.2 feet? So basically we're just going to plug in 2.2 instead of 2, and then we're going to just subtract the two things to find the difference. So we would have 4 pi times 2.2 squared. Help if I turn my calculator on first. And obviously we're going to need to multiply through by pi to get a number, which we're going to have to go back and multiply this other one as well. So for this one, I get 60.82. I think they're going to 2 decimal places. Yeah, that's fine. And then this one up here, 16 times pi was 50.27. So then subtract that. I get 10.55 feet cubed is the difference in the two. Now this is always throwing me off. The book answer is like 11 something, but I think they're either rounding or they're not rounding, and I'm not sure because obviously we rounded. So they could be rounding to a different value, which is giving it, but it's close enough that it doesn't matter. So anyways, any questions on those? All right, so problems. Not a ton, obviously. If you want to look through and do some more, you can, but one, 9, and then 11, but just part A and B on 11. And then 15, 21, again, just on that one, parts A through, wait, because is that the one we did? 20, we did 20. Yeah, just parts A through C on 21. And then 23, and 42 and 43 are multiple choice questions that are just kind of like AP type questions.